3, function notation. So that C of B stuff that we just talked about in our warm-up, we're going to actually use some function notation here. What I would like you to do is on page 69, I want you to match your equation or your function with its graph. I will tell you one thing that would help you out is to be able to use your y-intercept if you know how to find that in your equation. All right? You guys get a couple minutes to work on it. All right, how many got it? How many have narrowed it down, like 50-50? Haven't even narrowed it down? Okay, first, how many have it? How many have narrowed it down? I mean, narrowed it down. Like, I know that these two kind of look alike, and these two kind of look alike. And which two kind of look alike up here? Which ones are my linear? A and B are linear. Okay? That means they have to go with B or D. Okay? So since A and B are linear, meaning they have the x to the first power, they have to go with B or D. What's the y-intercept of this one? Okay, well, let's focus back. Recall from 8th grade, y equals mx plus. Okay, the number in front is your slope. Thank you. The number behind is your y-intercept. Okay, what's my y-intercept for letter A? Negative 3. What's my y-intercept here? 2. Okay, so look at your y-intercept. Which one crosses at negative 3? B. There's negative 3. Okay, so this is the equation y equals 2x minus 3. Which you'll notice instead of saying f of x, I said y equals. You can replace y and f of x. You can kind of interchange them there. Okay, this the y-intercept is 2. Here it's 2. So g of x equals x plus 2. G of x, that's just another way of saying y equals. It's function notation. So these different notations we're using today, f of x and g of x, they're just saying f is a function of x. Okay? This depends upon that. F depends upon x. It allows us to have an input location. Which one went with this one? What equation? Or what function, excuse me? C, which is h of x equals x squared minus 1. Okay, so letter C went with it. And this one then was letter D, 2x squared minus 3, and that's equal to j of x. All right. How many got it? Okay. We are going to, let me pause there for a minute. Okay, so the next page, exploration 2. Says work with a partner, consider the following function. F of x equals negative x plus 3. Locate the points x, f of x. Well, here's what we need to understand is f of x actually it's the same value as y. Okay? We just use them interchangeably, f of x and y.
Does it always have to be x?
What? Does it always have to be x?
No, does it always have to be f?
No, it could be f of x, g of x, j of x, k of x. As you guys, when you get to advanced algebra, so algebra 2, you'll be, how many are freshmen this year? You guys will be taking that your junior year. Okay, how many are 8th grade? You stay on this track, you'll be taking it your sophomore year. 9th graders, you'll be taking it your junior year, and then at the end of the junior year, consequently, you'll be taking your SBA test to graduate from to fulfill your high school math graduation requirement. 8th graders, you'll be taking and then maybe continuing into pre-calculus. Okay? You have to have a good foundation for function notation. Okay? So if you can take away that f of x is the same thing as y, and then understand that when we utilize f of x, it allows us to put values in for x and to get an output value. It's like having a keyhole. So when it says f of x equals negative x plus 1, it says locate the points x, f of x on your graph, and explain how you found each. Well, this means negative 1 and f of negative 1. If I go over here to negative 1 and then find f of negative 1, well, that means... Yes, negative 1's over here. Thank you.
Okay.
And then f of negative 1 is where it hits the graph. So what's the value of f of negative 1? It's 4. So this thing equals 4. Okay. I want you to locate those other points and then tell me what f of 0 is, and f of 1, and f of 2. Use your graph. All right, what is f of 0? 3. Okay, follow your graph at 1, you get to 2. And follow your graph at 2, you get to 1. How many have it? How many can prove that using your equation now? If I'm telling you your equation is f of x equals negative x plus 3, and then we're saying f of negative 1, that means, what did I do to the x?
Divided by...
Here, what's that?
You discovered the value for x.
I found out the value for x. So x is negative 1, so that means everywhere where I have an x, I'm going to put negative 1. Everything else stays the same. Well, what's negative 1? That's 1. And 1 plus 3 is? That's 4. Is that what we got? Yeah. Okay. Let's input it here. So if I use the same equation, f of x equals negative x plus 3, I want you to input f of 0. Write your equation. Notice the only thing that changes is the x part. X is 0, so we're going to put 0 in for x there. The negative stays there. What do we get? Yeah, we get 3. Okay? That's how we're doing input-output. So if I came down here and did this last one, f of x equals negative x plus 3, I'm going to do f of 2. That means I'm inputting 2 for x, and I get an output of 1. So f of 2 equals 1. All of these represent coordinates. This was the coordinate 2, 1. We found that on our graph right here. This one was the coordinate 0, 3. Found that on our graph right there. This one was the coordinate negative 1, 4. That's on our graph right there. Okay? That's how we use function notation. Not a big change from y or anything like that. Okay, everyone rate themselves 1 to 5. 5, you got it? What kind of questions we got? Okay, try this one then. So for those of you who haven't got this, when we put something right here, that is our input value. Once we do all the math, that's going to kick out an answer, which is an output value. Okay. A lot of times you'll see this reference as a function machine, but I'm putting in, what's my first input? It's 2. So we put in 2 there. That means everything stays the same except for the x. The x is the part that's changing. Put 2 in for x, and we get negative 8 plus 7, or negative 1. So when my is 2, my output is negative 1. Okay, I want you to write your ordered pair that you just came up with there. A point you can graph using that. Okay, what was my ordered pair here? The input and the output. How many got it? Okay, so how can you have multiple inputs? Like, how can I have x equaling two different things? Yeah?
The absolute value.
No, it's not absolute value. Think about a graph for a minute. If I have a graph that looks like this, and I put an xy axis here, can that graph does it have multiple x values? Yeah, it does. Right? Like here x equals something. Here x equals, like here x equals -1, x equals -2, x equals -3. When I put those inputs in, I get a different output. Yeah?
So, for that first part of the problem, would it be f in parentheses 2 equals -4, in parentheses -2, because x is 2 and then x equals -2?
No, you're putting in the same, whatever you put here, you have to plug in right here.
Oh, so why would x also be -2?
So we're going to do another problem and come up with another coordinate to plot. So when I put in -2, I put that in here. I put -2 here also. These two values are the same. So that gives me 8 plus 7, which is 15. So what is my coordinate for this one? -2, 15. So, guys, if I'm graphing this now, like if I want to graph the line f of x equals -4x plus 7, how many points do you need to make a line?
2. At least 2.
At least 2, right? So if I
3 would probably be that.
if I have this grid, okay, and my xy axis, I'm going to do this really quick, but here's x, here's y, here's an input, here's an output. Input of 2 gives me an output of -1. That is a point right there. Okay, with the ordered pair 2, -1. Input of -2 gives me an output of 15. So we're like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So I got to extend my line. So I'm like way up here. Okay, -2, 15.
That's 16.
You sure?
I think. Yeah, because you count 15 was first line up.
Can we call it 15?
Sure.
All right. -2, 15. So by finding two input outputs, it allows me to graph the line.
No, that's 15.
Make sense? Okay. All right. Any other questions? Okay, give that a go. So, hey guys, reading through this, f of t is the outside temperature in degrees Fahrenheit, t hours after 6 a.m. You need to go. Yeah. T hours after 6 a.m. What's that mean? Yeah, it means how many hours after 6 a.m. So, what did t become in this problem? 0. T, what was t is now 0. So, how many hours after 6 a.m.?
You're at 6 a.m.
0. So, what time is it right here?
6 a.m.
6 a.m. And at 6 a.m., what's the temperature? 58 degrees. Okay, so at 6 a.m., it's 58 degrees out. That's the meaning of that statement. Okay, what does that mean? All right, tell your neighbor what B means, or at least what you think it means. You have to step out of your comfort zone a bit.
Means that 6 hours after 6 a.m. temperature is nobody knows. It's too cold out for them to care.
Okay, what time is it right here? Yeah, it's 12 noon, right? So at 12 noon, it is what temperature?
Hot enough for the AC.
Yeah, it's in degrees Fahrenheit. We have no idea. It's a variable. May not make sense to you, but that's what it's saying. Okay, what time is it right here?
9 in the morning.
9 a.m. We add 3 hours to 6 a.m. What time is it here?
6.
Come on, we start at 6 a.m.
It's 4 p.m.
We had 9 hours. That's
3 p.m. I mean.
3 p.m. So what's it saying there?
That 3 p.m. is the temperature will be greater
Good.
than 9.
Yeah, the temperature at 3 p.m. is greater than the temperature at 9 a.m. Or at 9 a.m. it's colder than 3 p.m.
We're in the desert.
Okay? So we have to learn to interpret these statements. That's how we use function notation there. Okay? Think we got it?
Yeah.
Questions? Dude, you guys are just amazing. All right, let's try this one. Last piece. Find the value of x so that the function has the given value. Don't be confused on this one. Number 4, write it down first. Okay, were we given a value for x or f of x?
F of x.
F of x. So this time we replace f of x with 21. That means we replace that with the 21. Okay, so this becomes 21 equals 6x plus 9. So don't confuse yourself. There are times when you're going to see f of something. Okay, so the difference between this, f of 21, and f of x equals 21, f of 20 would actually say 6 times 21 plus 9. That's f of 21. Okay? So note the difference between the two. This one says f of x equals 21. That means you're inputting right here in your f of x and then looking for an output. So I subtract 9.
Yeah, I did right.
Get 12.
Yeah.
Divide by 6. My x is 2. So what's your ordered pair?
21,
2, 21.
Why is it 221?
X, and then f of x. Okay. All right.
I thought it was input output, though. Like so.
Okay, try number 5.
Okay. Nope, don't put it.
Get rid of that fraction by multiplying by the reciprocal. Negative 2 over 1. We're not going to get to those today. Okay? How many got it? All right, you guys, that's how we graph things. If we can pick multiple inputs or outputs, we can come up and graph them. Okay, I want you to take a look at your student journal, please. Page 72. Okay, your assignment today in your student journal, page 72 and 73. 72 and 73. Yeah, all 11 problems on page 72 and all 3 problems on page 73. So all 14 problems in all. Yeah. I know, it's called homework. We are in high school. It'll be okay. You can do it. All right, let me know if you need help.